prove by mathematical induction that 1 plus 2 plus 3 plus plus n equals to n all in bracket n plus 1 close bracket all over 2. Okay, we write solution. Amen. 1 plus 2 plus 3 plus plus n equals to n all in bracket n plus 1 all over 2. Okay, what we will do here is we are going to consider three properties here. One, P of 1, that is if n is equals to 1 or 2. Amen. Or sometimes you may see P of n, that is, it implies that n it could be 1 or 2. Then 2, P of k, that is, it implies that our n, assume n to be equals to k. Then the last, and not the least, 3, P of k plus 1, that is, it implies that our n is equals to k plus 1. Amen. So these are the three properties we will consider. Okay. So if you agree with me, let us assume n equals to 1. Assume n equals to 1. If we assume n equals to 1, we know that we have 1 here. So it implies that the left hand side, this one will be equated to this right hand side. That is, 1 is equals to n all in bracket n plus 1 all over 2. Amen. Okay. So if you agree with me, this implies that anywhere you see n, you substitute in for 1. Then we now write 1 is equals to 1 all in bracket 1 plus 1 all over 2. Then 1 is equals to 1 all in bracket 1 plus 1 is 2 all over 2. It means this and this will go. It implies that 1 is equals to 1. You discover that the right hand side is equals to the left hand side, or the left hand side is equals to the right hand side. This implies that we will now conclude by saying it is true for n equals to 1. Are you following? Okay. Let us assume n equals to 2. Assume n equals to 2. If we assume n equals to 2, it implies that, look at what you will do. I know some of you will go ahead to write 2 equals to n all in bracket n plus 1 all over 2. Please, Malians, listen very carefully. Is that clear? It is not so, but this is what you will write. Since our n is equals to 2, we are going to count 1 plus 2. It means the left hand side will be 1 plus 2 equals to n all in brackets n plus 1 all over 2. Then this is equals to 1 plus 2 is going to give you 3. Then this is equals to, anywhere you see n, you write 2 all in bracket 2 plus 1 all over 2. This guy and this guy will cancel. You discover that our 3 is equals to 2 plus 1. It will give you 3. It implies that the left hand side is equals to the right hand side. Therefore, we conclude by saying it is true for n equals to 2. Okay. Let us consider n equals to k. Amen? Okay? So if you agree with me, let us assume n equals to k. So if you agree with me, it implies that we write 1 plus 2 plus 3 plus plus n k is equals to n all in brackets plus 1 all over 2. Amen? So it implies that our k is equals to k all in bracket k. Anywhere you see n is your k plus 1 all over 2. It is not necessary you prove for the k. We conclude by saying that it is also true for n equals to k. Okay, let's look at the last but not the least. Is that clear? Please listen attentively. Okay, so if you agree with me, we assume n equals to k plus 1. Assume n equals to k plus 1. If we assume n equals to k plus 1, what we will do, please listen very carefully. We now write 1 plus 2 plus 3 plus plus k. This k, then plus, we said assume or let n equals to k plus 1. So we'll write k plus 1 equals to n all in bracket n plus 1 all over 2. Amen? So it implies that the left hand side will now be k plus 1. Look at it. K plus 1 equals to, you said assume n equals to k plus 1. So anywhere you see n in the right hand side, you now write k plus 1 all in brackets, k plus 1 plus 1, amen, all over 2. Do you understand? But note that this your k, look at it here. This your k is equal to k all in bracket k plus 1 all over 2. Amen? So instead of this k, we substitute in by this value, this guy. So instead of the k, we now write k all in bracket k plus 1 all over 2. Amen? Then plus k plus 1 equals to all in bracket k plus 1 open brackets k plus 1. If you open this bracket, we'll have plus 1 again. Is that clear? All over 2. Amen? Okay, so if you agree with me, let's multiply out this bracket. If we multiply out this bracket, we have k squared plus k all over 2 plus k plus 1 equals to, the right answer will now be k plus 1 all in brackets k 1 plus 1 will give you plus 2 all over 2. Amen? Okay? So if you agree with me, let us look for the LCM of this left hand side. LCM, note that is 1 here. The LCM of 2 and 1 is 2. Is that clear? So let's write 2. 2 to 2, 1. Then 2 times k square will give us 2k square and plus 2 times k. 2 to 2, I mean 1. Is that clear? Not 2. 2 to 2 is 1. So 2 to 2, 1. Then 1 times k square will give you k square, and plus 1 times k will give you k. Is that clear? Please take note. Then plus 2 to 1 plus 2 to 1, 2 to 1 to 2 times k, it will give you 2k, plus 2 times 1 will give you plus 2, equals to, let's multiply out this bracket. If we multiply out this bracket, k times k will give us k square, k times plus 2 will give us plus 2k, and 1 times k will give us plus k, and 1 times 2 will give us 2 all over 2. Amen? Okay? Without one telling you, look at the left hand side and the right hand side. It seems they are equal, true or false. Okay? So we know that we can add our k square, k plus 2k will give us 3k plus 2 all over 2. Amen? Equals to k square, 2k plus k, it will give us 3k plus 2 all over 2. You discover that the left hand side is equals to the right hand side. We can conclude by saying that it is true for n equals to k plus 1. Any question? No question? Thank you very much.